Let's just move on. All right. So if you recall, on Friday, we did some work with trying to find the slope of a line, or slope of a curve. But what we talked about is we were doing it at one point, and what was the problem with that? No, that was not the problem. What is the problem or the issue with trying to find the slope of a line at one point? Natalie? Yep, you need 2 points. Mason, you're going to want to focus. You need 2 points to find the slope of the tangent line. So first, let's draw a picture of what I mean by the slope of a tangent line at a curve. So I'm going to just draw a function that looks kind of like some kind of maybe a cubing function. It doesn't have to be anything exact, but just something that has some curve to it. And tangent lines at specific points, if I would make a point, let's say right over here, the tangent line is just a little line that nicks or just touches that curve at that point, okay? And so as we move along this line, like let's say I wanted to do a tangent line right here, so curves have tangent lines at all different points. If, for instance, I wanted to do a tangent line here, I'm hoping you're seeing that the slope changes, right? Isn't the slope steeper there? Okay, and as my rate kind of slows down, let's say I was talking about here, at that tangent line, it's a little less steep. What's going to happen if I continue to go up this curve is it's going to continue to get steeper again. What if the curve starts to decrease? What kind of slope would those lines have? Negative slopes, okay? So slope of a tangent line is essentially just a slope at one point, or the slope of the curve at a specific point. Okay, so as some of you are going to move on in math, there are two other vocabulary words that we use for the slope of the tangent or the slope of the curve at the point. The one is called a derivative, and that is, I think I mentioned this in class, all first semester in calculus we study derivatives, and so all a derivative is it's the slope of a tangent line. Another phrase or vocabulary term that we use for the derivative is instantaneous velocity. Was anybody in here in physics this year? Okay, so some years I'll have people who are in physics. So let me just kind of talk about instantaneous velocity, and hopefully you can understand why it connects to the derivative. So if you had a car driving and it went 300 miles in 2 hours, what would be its velocity? If you had a car and it traveled 300 miles in 2 hours, what would be its velocity? 150 miles per hour. Does that mean that that car was traveling 150 miles per hour that entire time throughout that trip? No, so that's its average velocity. The instantaneous velocity would be the the velocity at a certain period of time. So if I said exactly at 5 minutes, what was its velocity? It's the same issue with that then, because I don't have a slope to do. I don't have the change, and I'm asking you to do it at a point. And so we connect those two in calculus as well. Okay, so we're going to get into the slope formula again. And so there's a couple ways that you're going to see this. So the formula for the slope of a curve, or the slope of a tangent line, at a point is called f prime of x, okay? That is the shorthand way of writing the derivative. So all that means is it's a notation thing, f prime of x. Okay. To find f prime of x, this comes from the slope formula. Remember what we did in class, how we kept picking points closer and closer and closer to the point we wanted? Do you remember that on Friday? Yeah. Okay, so what we're going to say is to find f prime of x at a specific point, we'll call that point A. So to find the derivative at a specific point A, what we're going to do is we're going to find the limit as x gets really, really, really close to A. We're going to pick a point really close by, and then we're going to plug it in the slope formula. Remember the slope formula was change in y's over change in x's? So we're going to find the change in x. Remember x is just really, really close to A, minus f of A over x minus A. Okay, now I'm just going to put a couple different formulas up here for you, and then we're going to just look at one of them. So let's say I said to you, here's my curve, here's my point A, and remember how I said I wanted x to be really, really, really close to A? Would you agree I could add a teeny tiny bit onto A? I'm going to call that point A plus H. And H is really, really, really tiny. It's really, what's a really tiny number? Close to what? 0, okay? So if I had this point over here and this was A and f of A, and over here I have the point A plus H and f of A plus H, another way of writing this definition, this is just another way of writing it, is the limit as H gets closer to 0, and then I'm going to plug this in the slope formula. What goes on top is f of A plus H minus f of A over A plus H minus A. What's A plus H minus A? If I did on the bottom, here's my change in y's are on the top. What's A plus H minus A? Don't the A's just cancel? Yes, okay. This is the one we're going to deal with mostly today. Do you guys see the issue with this? Go back to what we learned about limits. Try direct substitution. Not only, okay, but hold on. What do we learn about direct substitution? Where are we supposed to put it? And top and bottom. When you put 0 up here, don't we get f of A minus f of A? What's f of A minus f of A? 0. If I put 0 here, I get, okay, but what do you know about 0 over 0? Okay, but what are we going to be able to do? Yes. So we're going to be able to find the slopes of tangent lines because this formula is going to allow us to use some of those techniques that we talked about earlier. Okay? Are you ready to do some math? Okay. So we're going to use that slope formula, and what we're going to do is we're going to find the slope of the tangent line of, let's do 2x squared minus 3 at the point 2, 5. All right, so we're going to try one together, and then I'm going to have you guys try one on your own. So what we're going to do is we're going to use this formula right here. And the point that we're going to use is 2. That's like my A. And this is like my f of A. Okay. So I know A is 2, and I know f of A is 5. That's my y value, okay? But when we do this, what we have to do is we're going to have to do some algebra. Who is good at algebra? Good. Do you remember how to square parentheses? You multiply it out by itself? Okay. All right, so let's first set up the formula. So the formula for slope is going to be, let's write down the limit as h goes to 0. And what was my, what did I say my a was? 2. So instead of f of a plus h, we're going to write f of 2 plus h. And then minus f of 2 all over h. Okay, so what we're going to do next, yes, Braden? I'm going to put it, right here, it is going to be 5. Yeah, I'm just writing the slope formula out, okay? Yes, but you are right. This is going to be my f of, my a is 2, and my f of a, I'm going to take that out and put 5 in its spot in a second. I am not going to do that here because I don't know what 2 plus h is, okay? All right, so I have my function. This is my function f of x. And as Braden pointed out, we know what f of 2 is. That's 5. But I'm going to do some work on the side here. You're going to do some work on the side. I need an expression for f of 2 plus h. So according to function notation, if f of x is 2x squared minus 3, f of 2 plus h means I'm going to take out the x, and what am I going to put in its spot? Just function notation. You're going to put 2 plus h in. So this instead is going to be 2 times 2 plus h squared minus 3. Okay, I said it was going to be mathy. I warned you. What do we do? This is where your algebra comes in. What do we do first to simplify that? Square the 2 plus h. Please don't call that 4 plus h squared. You just are killing cats. What's 2 plus h squared mean? Yeah, it means this, right? Okay, let's do it. So I have that 2 out in front. What's 2 times 2? 4. 2h plus 2h is 4h plus h squared. Okay. Would you guys simplify that all the way for me, please? Did you get 5 plus 8h plus 2h squared? So the reason why I have people do that on the side is that would be, I had to do a lot of work to evaluate that. Some are less work than others, but that is what I'm going to put in for this. And if I had tried to put it in there, there wouldn't have been enough room to do that work. Okay. All right, let's put it in the formula and let's try to figure out the slope. So we have the limit as h goes to 0. We found f of 2 plus h to be this entire thing. So that's what I'm going to put here. So 5 plus 8h plus 2h squared. Okay, minus f of 2. What did we say f of 2 was? 5. Oops, I don't need another parentheses. And then over down here we have an H. Okay, we're trying to get things to cancel. Do you notice anything on the top that cancels? Fives. Okay. Do you notice that each of these things has an H in it? Okay, as long as they all have an H, it's not killing a cat to divide it. So you may divide each of these things by H. What's 8H divided by 8? 8H divided by H. 8. What's 2H squared divided by H? Okay. I am able to evaluate the limit right now. I got the H's to cancel. Now let's plug 0 in for H. Okay. Now you might be thinking, what? That's a lot. What did I just find? If you were to graph this curve, I'm just going to draw a picture of this curve. It's a parabola opening up, move down 3, and it goes through the point 2,5. At the point 2,5, this tangent line has a slope of 8. That's what I just found. Okay.